Progress begins with an idea, with curiosity for knowledge and a passion for engineering. Each step builds the foundation for what comes next. A new system, a new standard. Growing partnerships, expanding horizons, creating, validating, and reimagining. Now, progress is accelerating faster than ever before, taking us into a bold new era, together.
Please welcome to the stage President Emerson Test and Measurement Ritu Favre.
Good morning, everyone. Welcome to Fort Worth NI Connect 2026. It is such an honor for me to lead Emerson Test and Measurement and our NI teams. That is never more true than when I'm standing here in front of so many smart and talented engineers. I'm so thrilled to welcome you back to Fort Worth. We do plan to be back in Austin eventually, but Fort Worth has quickly become our home away from home. Everybody keeps telling me to embrace Cowtown. I'm trying really hard and start to wear a cowboy hat, but I don't think I can do that yet. Maybe next year. Now, this is a very special year for NI because we are celebrating two major milestones. First, 50 years of NI innovation. Since 1976, NI has stood for something very specific: empowering engineers and scientists with a better way to test and measure the world around them. Very few technology brands can maintain that kind of relevance for 5 decades. In fact, only about 4% make it to 50 years. When you look across the technology sector, companies like Apple, also founded in 1976, and Microsoft come to mind. These are organizations that did not just last, they shaped the world that we live in today, including serving as the foundation for virtual instrumentation. The second milestone that I'm really excited about celebrating is 40 years of LabVIEW. From the very beginning, LabVIEW has challenged conventions. Graphical programming was not considered real programming. People said it wouldn't scale and that it couldn't keep up with C, Java, and eventually Python. They said it couldn't handle large applications, real-time systems, or FPGAs. And yet, decade after decade, we have embedded new technologies and capabilities into NI's platform. Those doubters continue to be proven wrong. I am proud to say, ever since I've stood up here, that we are still the LabVIEW company. We're still evolving our platform with the latest technologies. LabVIEW has always been the kind of coding, this is a little corny, that gave good vibes, long before anyone talked about vibe coding. But the 40-year legacy of LabVIEW is not just about a programming language or a graphical system design environment. It is about test and measurement, and most importantly, it's about you, the engineers and community who have used LabVIEW to test everything from life-saving medical implants to satellites in space. So I want to give all of you a round of applause for helping to revolutionize an industry. So today, the question that I hear most often is, what's next? There is no doubt that we're living through a period of massive disruption. Let's talk about AI for a moment. AI is not only disrupting the products that you all are building, it is completely disrupting the way that we approach test. For many, this might invoke some fear and uncertainty. I believe that for those of us that are in test, this is actually the biggest opportunity of our careers. I've seen this before. When EDA tools transformed semiconductor design, the best teams did not disappear, they just built better chips. AI follows the same pattern. It does not replace engineering judgment, it raises the bar for it. If you are in this room, you are uniquely prepared for this AI disruption. You have already embraced a software-centric approach to building test and measurement systems, and we are prepared also. We are investing in our platform where hardware and software seamlessly interoperate with the best of CPUs, GPUs, and FPGAs. It's a platform that can measure from femtoamp to sub-terahertz. It's a platform with software that spans from capturing a single data point to analyzing enterprise-wide results. And it's a platform that is ready for AI. That's why we're focused on delivering AI specifically tuned for test and measurement with Nigel. Over the next hour, I'm really excited for you to learn more about Nigel's new capabilities, like authoring code and test sequences. You will also hear a lot about our vision for an agentic future. Here's the point that I want to leave you with. The next few days will absolutely celebrate our history and legacy of the past 50 years. But we're even more excited to share our vision for what comes next. The advances that we're seeing in AI are among the most transformative that I have ever witnessed in my career. But this moment is not just about AI. It's about all the capabilities it will unlock in a new era of test coming into view. It's a future where AI is revolutionizing the way engineers approach test and measurement, and where engineering expertise is more critical than ever. At the heart of our past and of our future is you, the engineer, the problem solver, the person that's turning ideas into products that the world depends on. I thank you all for being the most essential part of the future of test and measurement. And now to show you a little bit about what this new era of test will look like, I want to welcome NI Fellow Charles Schroeder. And with him to say hello is our very, very special guest, NI co-founder and longtime CEO, Dr. James Truchard.
On behalf of the NIers and our customers around the world, thank you for your incredible innovation. Thanks, and
thank you so much for everything you did to build such an amazing legacy and such an amazing company. NIers around the world, thank you for everything you have done.
It's very exciting for me to see the continued innovation driven by the intensity and vision on what we've done, started 50 years ago. And I'm looking forward to seeing the rest of the show. Come find me, I'll be around this week.
Thank you so much.
Dr. T, it is such a pleasure to see you back on this stage with us. I think we're all looking forward to having you, and please do take him up on his offer and come find him this week. It is really a special opportunity to have you here. Thank you, and I hope you enjoy what we have to show you.
Thank you so much, Charles.
That is a hard act to follow. You know, this year, as we mark our 50th birthday party, we are simultaneously celebrating 5 decades as the most innovative company in test and measurement, and we're kicking off the next 5 decades of transformative innovation as we reimagine the productivity of test engineers. Now, as a technologist, I can tell you I am super excited to be here right now and what I believe will be the doorstep of the most transformative technology evolution of any of our lifetimes, and along with you to have the opportunity to play even a small part in how that turns out. If you've been with us over the years, you may have heard us use the phrase, the genius of the and. This was a phrase that Dr. T adopted from the Jim Collins classic book, Built to Last. And Collins believed that the most successful companies on the planet were the ones that embraced the seeming paradox of being both stable and innovative, creative and disciplined, profitable and purposeful, and being based on strong core values and being completely open to revolutionary change. And at this moment in time, as we're standing on the threshold of this tremendous AI technology inflection, I'll assert to you that embracing a genius of the and mindset has never been more important. So let's talk about what I mean about that for a minute. All right, for you, you are your company's greatest assets, period. The test systems that you design, build, and deploy are complex, business, and mission-critical systems, and their success depends on you. So you absolutely must build them on trusted and proven technology. And at the same time, you've also got to embrace some of the latest AI technologies because your companies are also counting on you to maximize your productivity, to deal with constantly increasing complexity, and to find innovative ways to improve your cost, your quality, and your time to market. It's not an or of the two. You have to find a way for it to be an and. And for us, as the team engineering the NI platform, we must continue to evolve our industry-leading platform of modular hardware, open software, data, and a thriving ecosystem of partners, and be able to reimagine and embrace completely new, potentially seemingly even competitive technologies if they promise to reshape your options for delivering on that need for better cost, quality, and time to market. Which means, as we reimagine the productivity of the test engineer, we must simultaneously build on the rock of the most trusted platform in test and measurement and do the difficult technical work, sweating the details and filtering the hype of a constantly evolving AI landscape. Now, the good news for all of us is that we are starting from an amazingly good place. When you choose to build on the NI platform, you're not only making a great choice today, but you're setting yourself up for the future. Because, and I totally mean this, and I will assert this and stand by this, the NI platform is the most AI-ready platform in our industry, period. Our modular hardware has the right size, weight, and power to be deployed anywhere and a diversity of I/O to meet your specific needs. It is the only platform in our industry with better than picosecond synchronization between instruments, and the only one that is capable of directly streaming measurement data into the memory space of a processor, like a CPU, an FPGA, and now a GPU. Our software is the most ubiquitous in the industry. LabVIEW is the only language capable of naturally representing parallelism, and the only one where on one screen you can target Windows, a real-time operating system, multiple different types of processors, and multiple models of computation. And with last year's launch of NI Nigel AI, we're already bringing software directly to our customers. Data. Now, data is a new area for us, but it is like oxygen for AI. And with powerful products like SystemLink and Diadem, we're really the only company in our industry that already has a broad-based data platform, and we're evolving that platform rapidly to meet your future needs. And for our partners, especially our alliance partners, man, you guys are the literally heart of our ecosystem. A big shout out to any of you that are in the audience today. We are so fortunate to have some of the world's best system builders as our partners and our friends. Thank you very much. And guys, they are ready to help you meet your toughest test challenges today. So this morning, for the remainder of the keynote, I want to focus on the strengths of the NI platform, both for today and tomorrow, and how the value of the and of our hardware, our software, our data, AI, and our ecosystem working together, that total value is greater than the sum of any of the individual products by themselves. So every day, trains and shuttles play a critical role in how cities and even economies function. But today's trains are, well, they're as much software and electronics as they are gears and motors. To share a little bit about how it takes a platform to test a platform, please help me welcome Chief Product Marketing Manager Brett Berger.
Thank you so much, Charles. I'm so excited to be here today. I've been working with this customer for a number of years, and I really wanted to share their story of how they've leveraged the decades of innovation we've poured into our platform. Now they're thinking about the future and how they'll use the NI platform to continue to bring safety, compliance, and customer success to a truly complex portfolio of products. If you flew here for this event, there's a good chance you rode on an airport shuttle at some point in your journey. That is a modern train system. That shuttle has controllers everywhere to manage traction motors, brakes, doors, passenger systems, and more. This company has used 3 generations of PXI-based test architectures, dating back to 2007. They developed their own test systems as their products have evolved with different features and use cases.
Yeah, and really that's the power of the NI platform, because as we've added new capabilities to both our hardware and our software, our customers have been able to immediately take advantage of them, like in this case. You know, our platform is able to scale right along the evolving needs of all of you, and that's a pretty important part.
It is. This company also uses PXI for their HIL tests, but to validate their mechanical components, we've helped them shift to more rugged hardware. They use Compact DAC and LabVIEW or FlexLogger in test cells for their traction motors, gearboxes, to help capture current, voltage, temperature, speed, and torque data. Now, once they have a fully working train, they're able to take portable data loggers out on the test track. They switched from Compact DAC to Compact Rio for the field because it's quick, robust, and standalone. They're able to just pack them in a box, carry them around. It's not as much to worry about. There's no better combination of integrated hardware, software, and data than the NI platform.
And I really like this story because this application highlights several key platform advantages, including the native parallelism of the FPGA with optimized algorithms and LabVIEW running real time, the ability to capture and stream data directly to disk, the ability to synchronize distributed measurements, and a size, weight, and power that allows them to put the measurements exactly where they need them. Brett, this is a great example you've shared with us today. Thank you so much for being here.
Thank you, Charles.
So software is, without a doubt, one of the most important elements of our platform-based approach, and that's why we're making literally massive investments in our entire software portfolio, including LabVIEW Plus, SystemLink, and Nigel. Just a year ago on this stage, we were excited to introduce you to Nigel, running in LabVIEW and in TestStand. And as an advisor, Nigel had detailed knowledge of our products, detailed information about software best practices, and gave you guidance on building test and measurement applications. Well, since then, we've been working really hard to expand Nigel's capabilities, leveraging the best of the off-the-shelf AI technologies. So, let's talk about what's next. Well, in the newest version of LabVIEW Plus, coming out this summer, we're adding brand new capabilities for Nigel as an author. And as an author, Nigel will be able to generate code and test sequences, will be able to create stunning visualizations, and will be able to surface meaningful insights buried deep within your measurement data. But it is so much cooler to show it to you than it is to talk about it. So to help me do that, please welcome Graham and Israr to the stage.
So thanks so much, Charles. I mean, the feedback we've had from our users has been clear. We like what you're doing with Nigel. Please go faster. I mean, game-changing technologies are coming to market that are defining a new era in test. And NI software is at the forefront of this, helping engineers make better test systems faster and smarter than ever. So set your countdown timers, because July 28th is the date you need, because the things we're about to show you here are going to change the way that you work every day. In this new era of test, you're going to be using Nigel AI for everything from your planning and system design through development, insight, and asset management. Test engineers who know how to use AI effectively will be more productive than those who don't. So, you said make all this real. Let's consider the concept of a physical test lab. Now here, technicians and engineers need to set up custom measurements quickly and independently. And Azra here is going to show the software we use for that is FlexLogger. Now this is our software for physical measurements and data logging. Now, vibe coding's quick, but having an application that does exactly what you need is quicker. And so this is where we'll start. We can set up our channel measurements. We can switch across. We can set up our logging, our alarms, our triggering, and we can display that live data from the microphone we have connected to the Compact DAC here on stage, right on stage to see our live signal. Now, that's great, but labs like the one that Brett was just talking about need custom requirements. And that means that the flex of FlexLogger, which is all about open extensibility, comes into play. So let's add some harmonic measurements to this basic signal. And in FlexLogger, we do this by using LabVIEW to create a plugin that can build in that functionality into our application. Now, in a new era of test, we can ask Nigel for help. And to do this, I'm really excited to talk about a feature that I know many of you have been waiting for. I'm pleased to announce here on the stage, LabVIEW code generation by prompt has come to LabVIEW. So. Okay. Now, let's see this for real. So Azra here is going to ask Nigel to make a FlexLogger plugin for us right here on stage. We're going to make a sound meter. So what it's going to do is it's going to, in LabVIEW, it's going to go to the Sound and Vibration Toolkit. And it's going to pull in, it's going to do some averaging, some filtering, it's going to do 24th octave analysis, and it's going to output the sound level that we can then log to disk. Now, that's the plan.
So what Azrar just asked Nigel to do is actually quite a bit more than just writing LabVIEW code. To make a FlexLogger plugin like this, it means setting up a LabVIEW project, complete with state machines, a class structure, user interfaces, and a lot of processing.
Absolutely. While Nigel's working here, let me talk you through what it's going to do. So we've taught Nigel how to make FlexLogger plugins. And so the first, based upon the prompt, it's going to go and look at the shipping examples to get trusted IP from both the FlexLogger plugin development kit and the LabVIEW Sound and Vibration Toolkit. So we can learn all those best practices. It now comes back together. It's going to create a project with all the structures and dependencies we need. And then we've asked it to focus on the process VI at the heart of this plugin. And so here it's going to create that VI with inputs and outputs, and then populate it with the state machine, architecture, and all the functionality that we need inside it. So Nigel's ability to author code like this is going to change the way that we develop in LabVIEW. But while we're showing a kind of a complete application here, you can really use Nigel for many of your day-to-day tasks, whether that be array manipulation or hardware connectivity. I mean, everybody this summer should be using Nigel to help them with their DAC-MX code. And then LabVIEW's ability to clearly represent the operation of your code, the parallelism, the models of compute, bringing in this trusted IP, add a rich debugging environment to that as well. I mean, LabVIEW has become a really strong choice for vibe coding test applications.
Yeah, and this is really actually compelling because while AI will allow you to vibe code in many languages, I think we all know that all languages are not actually equal. LabVIEW's graphical nature makes viewing and debugging sophisticated test applications far easier than text-based code. And now test engineers don't have to choose between vibe coding with a large language model or LabVIEW. They can have the benefits of both.
Now, before we return, I want to talk a little bit about some of the other features coming to the software platform. So for Nigel, since February, it's been able to have context of your local hardware. And so this is important because it gives you more practical answers, things you can act upon. It's also been able to review and have context of your LabVIEW projects and your test stand sequences, meaning you can look for those dependencies that are, or functionality within them, or maybe ones that are missing. And then starting from July, Nigel will be able to not only have context of your test stand sequences, but it will be able to write test stand sequences too. It's also going to come to Instrument Studio, to FlexLogger. It's going to come to VeriStand. And of course, we're going to be able to deploy that on private cloud instances as well, which will open the door to many of you I know here in the audience. Now, beyond Nigel, we have a host of new features coming to the LabVIEW Plus suite too. From Unicode, front panels coming to LabVIEW. We've got test and deployment on Linux. We have over 60 technical software sessions here throughout the conference and a host of demos on the show floor staffed by our R&D engineers. So please do go check out all of those to learn more about our new features.
Graham, I think you just said a lot, and I hope you guys get the sense that we are innovating fast. But let's get back to that Harmonic plugin demo. Asrar, what have you and Nigel built?
Charles, I'm happy to share that Nigel did everything we had asked it to do. It created this LabVIEW project, including all the VIs and dependencies that we need.
Go on, give Nigel a round of applause.
So for this demo, we had asked Nigel to focus on the process VI, as that is the heart of our plugin. So let's take a look at this VI. All right. Nigel built this VI using class-based state machine architecture that it pulled from the FlexLogger PDK. Nigel also implemented all the logic you see here using the sound and vibration functions from our LabVIEW toolkit. Since we asked Nigel to create a FlexLogger plugin, it also went ahead and built this project so it is ready to use within FlexLogger.
Okay, so if we switch back to FlexLogger now, we can see how, as we've built that plugin, Asrar can reference the sound signal we have from our audio here, and then we can instantly see that in our user interface. And you could log this just like any other calculated channel in FlexLogger. So here we go. So we should give this a try. Now, unfortunately, unlike Brett, we don't have a train here on stage. So instead, we're having what we're calling a train output module for big orchestral noise emission. You see what we did there? Okay. You ready? We're going to give this a go. Make some noises.
Let's do it.
A big round of applause for Graham here. You guys didn't know you were getting a keynote and a concert, did you?
Okay, it's a bit much, but I wanted to make the point in a way you'd remember it. Because what we just did here, or what Nigel and Asrar just did here together, is in 4 minutes or less, we created a complete application, bringing in trusted IP, connecting to the real world, and building a user interface. Now, general purpose AI tools struggle to do this. Nigel, no problem at all.
Yeah. And as cool as that is, coding is just one of the tasks that Nigel can help you do across your workflow. And once you've written and run your test applications, you then start the time-consuming task of working through all that data, mining it for insight.
Absolutely. Now, in this new era of test, we have huge expectations coming in on the data that we have. And that means we've got to step beyond just the measurement data that we're taking and have the context around how that data was taken and the metadata around it. Because if this context can be standardized across all of the systems in your lab, it allows you to ask some really interesting questions to Nigel and get some even more interesting answers back. So let's show you. We're going to return or stay on our acoustic test demo here, and we're going to connect FlexLogger into SystemLink. Now, if you're not familiar, SystemLink is our software for connecting all the systems, visualizing your data, performing analytics, and measuring your test and managing your test assets. Now, to do this, thankfully, is as easy as clicking the Connect to SystemLink button, and so, boom. Now, all of our data from this demo is referenceable alongside a larger repository of data that we're using to simulate an active lab over the last couple of weeks. Asrar, what can we ask about it?
Yeah, so here in SystemLink, we can see each of our previous test results. But as you can see, this raw data is not easy to read. With Nigel and SystemLink, we can quickly find outliers or identify concerns. Since we are on a musical theme here, let's ask Nigel to show us this information in a violin chart, showing us the distribution and probability density of our results. Nigel, plot the data with distance on X and color by temperature, and show that as a violin chart. With Nigel, getting insight into our data is as simple as asking. Just ask Nigel.
Boom, look at that. That was quick.
All right. Yeah, here's my new graph. So yeah, within seconds, I went from looking at raw data to an organized color-coded chart. Isn't that cool?
That's super cool, super cool.
And right here, I can clearly see now we have an anomaly with our data. Okay, I need to alert my team at Charles Schroeder. Charles, I have an action item for you. Please see this data set, stabilize lab condition, and rerun Charles.
And it is a cruel world when you can get an action item in a keynote.
But so for small labs and simple labs for as few as 5 systems up to huge multinational enterprises, the latest versions of SystemLink are available to all engineers. And I'm excited to announce that Nigel will come to SystemLink later this year, and it's on the trade show floor right now, so please do go check it out and talk to the engineers there. Because Now, from code generation to data and analytics, we are so rapidly evolving, Nigel, in so many ways across your whole workflow of all of the tasks you do. The new capabilities that we saw today really do mark a new era in test, and they will come to you in July. So I cannot wait for you to get your hands on them, and thank you so much. Thanks, Charles.
Thanks, Charles.
Incredible how far you can come in a year. So our next application points us to the sky and beyond. Human spaceflight is continuing to advance very rapidly with incredible and exciting missions like the recent Artemis II. Now, it turns out that moving at the speed of sound through Earth's atmosphere at multiple times the speed of sound, that's just hard, and it creates a lot of things to test. So to tell us more about how our customers are literally approaching this mission-critical application, please help me welcome Chris Davis from Momentum and Sarah Zaleski from JKI. All right, so Chris, tell us what you and the team at Momentum are doing.
Well, thanks, Charles. So when people hear the phrase faster than the speed of sound, they might think about an airplane traveling at supersonic flight or anything above Mach 1. But when a spacecraft like Orion re-enters the Earth's atmosphere at 25,000 miles per hour, the physics changes considerably. A few weeks ago, we all had an excellent opportunity to witness Orion returning safely to Earth using heat shield materials that were tested at hypersonic speeds to ensure that the astronauts would survive temperatures above 5,000 degrees Fahrenheit. And quite frankly, most wind tunnels just can't do that. That's where we at Momentum come in. So getting air to move at hypersonic speed takes a lot of energy. You need large amounts of high-pressure air and cooling water, and as much electricity as a small city to create the test conditions required to perform this kind of destructive testing. With that much energy blasting the test article and the test cell, making split-second decisions about the test objectives are critical so that we don't damage the test article or the test cell.
Yeah, and I've seen many wind tunnels over the years that use big turbofans, but this sounds like it's totally next level. So how did the NI platform help you?
Well, Charles, our customers generally understand how their test articles should behave under these kinds of harsh conditions, and the test cell engineers understand the limits of the test cell. So we needed a platform that allowed our customers to control a test while monitoring the test article and the test conditions to make decisions about stopping the test or moving on to the next test article. So to help provide our customers with the best testing environment possible, we needed to collect a lot of data. We needed to move that data around the system very quickly. We needed to compare measurements to our data model, and then we needed to close the control loop with minimal lag. The NI PXI platform was excellent for this application because it gave us the connectivity we needed to other systems with a powerful controller running a real-time operating system for control. We've also got full access to the data from the test cell and the test article for rapid decision making. So if we're running a test and conditions deviate too far from the limits, we can fully abort within milliseconds.
Yeah, and I think this is another great example of NI's platform of integrated hardware, software, and data capable of solving test problems beyond the limits of other measurement platforms. And Chris, I imagine that given this is in a government application, cybersecurity must be a key requirement.
Yes, it was, Charles. Because of government regulations with CMMC in the United States and CRA in Europe, security is more important with every project that we tackle. So to satisfy these security requirements, we needed to prove that our system was safe and secure, including both that we use secure tools and that we use them in a secure way. That generates a lot of documentation, and it can be a very large effort. And that's why we're using JKI's security suite to help us with that process.
So, Sarah, can you tell us about how the team at JKI are helping Amentum?
Of course. Many of our customers require cybersecurity. Traditional security tools are designed for text-based languages and focus on memory issues. LabVIEW is different, so the risks are different. The JKI Security Suite provides a set of tools that analyze the risks to the system from a LabVIEW perspective. It analyzes code to look for those risks and documents how risks are addressed. The JKI Security Suite can also generate a software bill of materials, or SBOM, directly from a LabVIEW project, streamlining a key requirement for standards like CMMC and CRA. And I'm excited to announce that starting with LabVIEW 2026 Q3, JKI's SBOM generation capability is built directly into LabVIEW, so every LabVIEW developer can generate an SBOM as part of their workflow.
Thanks, Sarah. And I believe this really highlights another key element of our platform, our ecosystem. Collaborating with great partners like JKI allows us to better meet the challenges of our customers' demanding applications. I'd highly encourage you to visit the JKI booth in the Expo Hall to learn more about their security suite and the new SBOM generation capabilities in LabVIEW. Chris and Sarah, thank you so much.
Thank you.
So we've talked about PXI, but to tell you more about how we're evolving our PXI hardware platform, please help me welcome from NI, Christina.
Over the last couple of years, we have released several new PXI modules that push the boundaries of what is possible. And earlier this year, we announced several new affordable PXI products which enable more engineering teams to build cost-effective automated test systems. And we're continuing this trend in RF with our vector signal transceivers. I am excited to announce Core VST, a new cost-effective tier to our VST family. Starting at 200 megahertz of bandwidth and providing sub-6 gigahertz frequency coverage, Core VSTs optimize speed, simplicity, and versatility for test engineers developing RF test systems. Core VSTs minimize cost while delivering high performance when automation and efficiency are critical. Another area we're investing in is making PXI's synchronization and streaming capabilities even easier for our customers, which is particularly important for applications with growing channel counts. Let's take a look. So here, I have a large LED panel, and I want to understand what is happening across the 16 independent digital lines that drive the output. I am using 2 of the new affordable 8-channel scopes you saw on the screen a moment ago. So doing this with traditional box instruments is a complex task due to the effort involved to align the numerous triggers and sample blocks. But with NI-PXI, we can turn multiple oscilloscopes into one unified instrument. Let's start by seeing how easy this is inside Instrument Studio. So Instrument Studio automatically picks up both modules and treats them as one 16-channel scope. You can see here, all the channels have the same controls, same UI. Now, if you look at the graph, you can easily see the data lines that correspond to the black bar that's floating across the panel. So to illustrate the incredible synchronization capabilities of PXI, we are measuring one of the output-enabled lines on both scopes, which I'm going to demonstrate in a new Instrument Studio panel. So here you can see Instrument Studio, again, automatically treating these 2 scopes as one. If I scroll here, you can see channels 7 and 11. They're actually on 2 different physical scopes in our chassis. Now, if you look at the data, I'm going to adjust the Y position. And there, you can see they're aligned, triggered together, and displayed like they're on a single device. So this is actually driven by a new feature in our API, in our driver, called synchronized multi-instrument sessions that works for any NI scope of the same model.
And using Instrument Studio, Christina, you've been able to automatically show 2 scopes operating as one, perfectly synchronized right out of the box with no programming required. But eventually we need to get to LabVIEW, right?
So traditionally, if you had 2 or more scopes, you would write separate sessions, synchronize them manually, fetch data from each one, and manage timing across the different instruments, like you see here. And if you needed even better synchronization, you could use the NI-TQuAC API to improve overall performance. But multi-instrument sessions makes this even easier. Here you can see the programming is dramatically simplified. Rather than create multiple sessions, I can create one that points to multiple modules, and all the synchronization takes place for me. Let's take a look. So in this VI, we are looking at the same digital line we saw in Instrument Studio, but I'm creating 2 parallel tasks. Now, you can see here the data, it's close, but there is some skew. Now, if I turn on synchronized multi-instrument sessions, you will be able to see the performance dramatically improves with this simplified programming experience.
Yeah, it's awesome, Christina. I think this is a great example of how our continuous investment in NI, we were putting into this platform all the way down to the driver. And I think you've got even more to show us, though, right?
I do. So with AI data centers consuming massive amounts of power, our industry needs new ways to measure different large amounts of reactive loads and transient responses coming from the compute elements to improve their efficiency. So to address these unique measurement challenges, I am excited to announce the NI PXI Express 4311, a high-performance analog input module for electronics power validation. With 32 high-performance analog input channels, engineering teams will be able to use the 4311 to make simultaneous real-time power measurements across several test points.
It really is great to see all the amazing investment in the NI PXI platform. Christina, thank you so much for sharing. So if we continue on this theme of using measurement technology to play a critical role in reducing energy, our next customer is finding innovative ways to reduce the energy consumption in the wireless industry. This industry accounts for about 4% of global greenhouse emissions. That's twice the aviation industry, and it's still rapidly growing. Now, most of that energy is being consumed in the cellular base stations we connect to every day, and wireless engineers have been working really, really hard to find innovative ways to improve the base station energy consumption without sacrificing link quality. It turns out that machine learning models are a promising new tool to help address this and to provide balance between power consumption and network performance. So to hear from a leading expert in this area, please welcome Dr. Shea from Yonsei University.
Thank you so much for having me. I've been using the NI's USRP in my research for the past decade to prototype next-generation water systems. My research has spanned from full duplex radios to 60 MIMO, and now I am researching how AI can be used to improve the power efficiency in base stations. I used USRPs to build the real-time testbed of the 6G network that I can customize and try out my ML model to see how they perform at a system level. So I can see how changes in my model affect the overall the water system power and performance, indeed, which is quite important. So I want to create a base station that uses as little power as possible, but still it needs to deliver robust connectivity and also good data rates to the end users. So I needed the measurement platform that could combine the wireless link emulation tightly synchronized with power the measurement. That may sound quite simple, but the timing and synchronization required to correlate the power measurement to the impact of the AI model especially on the RF1 signal, is incredibly complex.
Yeah, it is incredibly complex. So what kind of power savings do you expect you can achieve?
Well, by my estimate, I think we can reduce the base station power consumption by 30%.
Yeah, I mean, 30% on 4% of global greenhouse emissions is a big impact. But probably like to see a demo of that. So to do that, please help me welcome Walter and Sarah. Now, you may have noticed there was no Sarah. We weren't trying to pull one on you. Sarah is actually on the expo floor, and she should be joining us by remote camera. Sarah, are you there?
Hey everyone, I'm just outside the keynote hall in the expo area, and behind me I have a replica of the power monitoring test bed that Dr. Che has in his lab in Korea. Let me show you how it works. In this server, I'm doing all of my measurement orchestration and recording my data for doing further AI training and processing. This server, USRP, and power amplifier are my real-time base station. And finally, I have a C-RIO with voltage and current modules that are connected up to multiple measurement points in my system. You can come by and see it in the expo area after the keynote, but for now, let me pass it back to Walter to tell you about the software.
Thank you, Sarah. So the software in this system is driving a highly complex application, leveraging real-time open source 5G and 6G implementations running across multiple CPUs and GPUs, across USRPs and a compact RIO. The hardware leverages streaming, synchronization, and real-time performance of the NI platform and captures a diverse set of data sources from the 6G system directly into NI's data platform. The amount of data captured in each configuration is massive, and AI algorithm optimization analyzes thousands of these configurations. So this is yet another use case where Nigel's data analytics capabilities will help to speed up development and effectively allowing us to use AI to test AI. And nothing of this would be possible without the USRP product line, which plays a key role in prototyping wireless systems for years. And today, we are excited to announce the new USRP X420. From 6G to radar to electromagnetic spectrum operations and supporting frequencies up to 20 gigahertz with the gigahertz of instantaneous bandwidth. This is our most advanced USRP ever.
So Sarah and Walter, thanks for the demo, and thank you, Dr. Che, for sharing your amazing story with us today. We're looking forward to seeing what you do next. So you just saw an example of research that's pushing the boundaries of innovation, including finding new ways to use the latest GPUs from industry leaders like NVIDIA. The NI hardware platform's unique ability to stream measurement results directly into the memory space of a processor makes it an ideal platform for integrating the next generation of GPUs. So to talk about how our platform is empowering an AI future, please welcome Adam Thompson from NVIDIA.
Thank you for having me, Charles. Modern instruments are producing more data than ever before, and new AI workflows are critical for handling this data deluge and drive towards autonomous experiments. But for real-time inference and an AI future, we need a tight coupling between GPU compute and sensor data at origination. With NVIDIA software tools optimized for real-time signal and image processing, along with NI's data streaming abilities, developers will have the ability to build the future of intelligent sensor processing, reducing the time to market and lowering the time to discovery.
Yeah, and as a technologist, I'm just super excited about what's going to be possible when the leader of GPUs is partnering with the leader in modular instrumentation. The flexibility of the NI platform provides many, many ways to integrate GPUs. The example from Yonsei University is one example, and they're using text-based tools. We also have third-party toolkits for integrating GPUs in LabVIEW. And now there's a brand new technology coming from NVIDIA called Holoscan.
Holoscan is an open source software development kit that gives developers a common high-performance API for building real-time AI streaming applications on NVIDIA GPUs. Simply put, it provides developers with a framework to easily connect high-speed sensors to AI inferencing, visualization, and application-specific CUDA code for GPUs.
It sounds like a very powerful tool, so let's welcome back Sarah and Sage to the stage. Did you sprint?
No, leisure walk. All right, so in our system here, we have a server with an NVIDIA RTX 4000 connected to an NI USRP X410 over Ethernet. The NI team has built an operator block for Holoscan that you can drop into any Holoscan workflow. This operator handles all the USRP configuration to stream data directly from any USRP to an NVIDIA GPU. And this empowers anyone to quickly create an AI testbed, even if you've never programmed a GPU before. Now, today, we're showing a signal identification application in Holoscan that was developed by Kaushik Chaudhry's team at UT Austin. As the USRP receives wireless signals, UT's machine learning-enabled application detects and localizes signals of interest within the received spectrum. USRPs can stream wide bandwidths up to 1 gigahertz, and by using a GPU, the full signal bandwidth can be processed in real time, which is critical for this kind of signal intelligence application.
Holoscan was simple to use, and we were able to take our ML model and get it set up and running in this real-time testbed. We built this testbed in a number of weeks, and even 2 years ago, this same testbed probably would have taken us close to a year.
So from faster analysis time to anomaly detection, we see tremendous opportunities for GPUs to play a critical role in test and measurement applications. Today, you saw 2 great demos of the technology and its integration with the NI platform. And we're excited to work with leaders and partners like NVIDIA and in continuing to enable and unlock a GPU-powered future.
Well, thank you, Sarah. Thank you, Sage. And thank you, Adam. All right, so earlier this morning, I mentioned our imperative to both evolve our current platform and to revolutionize how test systems are designed, built, and deployed. At the core of our platform are software. It is key that AI is fundamentally changing the way many of you think about and use software across your workflows. And because of that, I want to talk a little bit more about the future of Nigel and how it will change the way you design, build, and deploy your test systems. Now, we've shown you Nigel as an advisor and Nigel as an author, but the future of test requires Nigel to have far greater capability. The future of test requires Nigel to become agentic. And soon, Nigel will expand beyond the current in-product experience to help orchestrate tasks across your entire workflows. And we're super excited about how this is going to accelerate your productivity as you shift from using purpose-driven tools to collaborating with an AI-first, outcome-driven Nigel agent. And that future, as exciting as it sounds, may be even closer than you think. So to see it in action, please help welcome Chief Technology Officer Kevin Schultz.
All right. As Charles shared, Nigel will be your T&M optimized, trusted, workflow, and context-aware agent. Ultimately, you need AI that moves you from agentic coding to agentic engineering. And that's exactly where we're taking Nigel. As an agent, Nigel will evolve from being embedded in individual applications to a standalone experience that supports your entire workflow and connects seamlessly to the tools you require. Nigel will work natively across LabVIEW Plus and SystemLink, while also integrating with the broader ecosystem of tools you use, including open source. It empowers you to decide when to rely on proven technologies and when to adopt new approaches, while maintaining the trust, safety, and professional workflows of the NI platform. Now, to do this, Nigel will utilize our decades of T&M expertise, industry-leading hardware and software, your rich contextual data, and the best technologies in the AI industry. The end result? You'll have the ability to unlock transformative insight and solve problems that were previously out of reach. Now today, I want to give you a sneak peek, an early look at how we're engineering Nigel to deliver the future of test. And while I do believe a picture's worth 1,000 words, a demo's worth even more. So please welcome to the stage someone you've seen up here before, NI Distinguished Engineer, Alejandro Barreto. Alejandro.
Awesome. Hey, everyone. I am stoked to be back here to share what the team has been building this last year.
All right, so Alejandro, why don't you drive the demo while I explain how we're engineering Nigel for the future of test?
Absolutely. But a quick note before we get started. We've cached some of Nigel's responses today because we have a limited time on stage.
All right, so one of the first things a validation engineer does is read the test plan and figure out what kind of test system they need. So after hours of just reading the test plan, the real work starts. Walking the lab, looking for available hardware, digging through documentation, spending hours online trying to select the right architecture from multiple options. This feels harder than it should be. So why not ask Nigel? So Alejandro, can you ask Nigel to design a test system for this power management IC?
Sure thing, Kevin. We can definitely do that.
Okay, so we've taught Nigel to read test plans, make smart, grounded recommendations based on expert-tuned skills and APIs. As Nigel responds, you'll notice something important. It asks follow-up questions to get more context. It knows which questions are important. It takes multiple steps to avoid hallucinating solutions that could damage your hardware or create safety risks.
Yeah, so Nigel right now is reading my test plan, and I've asked it, what hardware do we need to test it? And it came back to me with a couple of options. And as the expert in the loop, I'm going to review these options and pick one before we keep going.
And the options Nigel returned are backed by 5 decades of our test and measurement expertise. And extensive information about the NI and hardware and software platform we've trained it with.
Yeah, because I want to reuse my hardware and I think I have an SMU, I'm going to pick option C. So let's do that.
So when designing test system, Nigel knows to connect to System Link. It can find your existing assets, check utilization, verify calibration dates. You don't have to prompt anything. Nigel just does it. Nigel connects to all your NI software. That means less time fighting general purpose AI with endless prompts and burned credits. No extra setup, no MCP servers to install. Nigel just works right out of the box. So, how did Nigel do?
Yeah, so Nigel did find the SMU that I thought I had because it's tracked in System Link. It knows the specs for all my hardware, no guessing here. But Nigel also noticed that my SMU is at 85% utilization, and it's not going to be much available this month. So Nigel suggested to get started, I can use this Keithley SMU as a substitute while I go and order a new NI one from ni.com.
I think you know that purchase rec's approved. Okay, so now that we have a plan, I think we're ready to move forward. Let's document it. Nigel updates your test plan and other documents to reflect what you've chosen. And we'll show you the changes as they're being made. As always, you stay in control, and you can directly edit the test plan alongside Nigel. This is how we maintain trust and visibility to make changes to your projects. Now, Nigel is also connected to version control. So Alejandro, why don't you finish up the test plan and pull it up for review, or put it up for review.
Yeah, absolutely. Let's open up our Git pending changes. Let me see here, we have one change. I'm going to open up the file, do a quick review of it. It looks good, so I'm going to stage it and say, hey, we're done test plan. If I can type. Commit. All done. What might have taken hours now only takes minutes. That's the power of Nigel. Now I'm ready to open up a pull request on GitHub.
Okay, so let's pivot. Let's pivot to the middle of the workflow. It's time to write and deploy your test procedure. I want to show you some ways Nigel is advancing with even more capabilities in these steps. So, Alejandro, let's test the power efficiency and quiescent current of the DUT we have.
Yeah, and so for this task, I'm going to choose Claude Opus 4.7.
That's important. You know, Nigel connects to the industry-leading frontier models and is model agnostic. You can pick the model that works best for the task at hand. Maybe you like GPT for brainstorming, Claude for code. Maybe you want to compare outputs side by side. You can even run models in your own cloud or Azure GovCloud if you have specific security requirements. You can even switch models mid-task. So as Nigel plans to implement your tests, it recognizes the value of reusing proven, validated code. So, Alejandro, what has Nigel found for these two tests?
Yeah, so right now, Nigel's looking through the entire repo, looking for BIs or other assets it can use in order to do this test. And so there's this is a pretty big repo, and it looks like it found VIs for the power efficiency test. That's great. It actually found 2 of them. But for the quiescent current test, it didn't find anything. So perhaps, yeah, should we have Nigel write a test for us?
Well, definitely. Now, you know, we already know Nigel can do it in LabVIEW. Graham and Asrar just showed that a little bit ago. So I want you to do it in Python.
Python. Now, come to think of it, actually, I have a Jupyter notebook that I got from a colleague the other week. Maybe I can open that up and use it as an inspiration. It's got the measurement theory for it. Let's go.
So Nigel is also language agnostic. It lets you work in any language you choose. LabVIEW, Python, C#, Rust. You choose the best language for the job. Nigel uses the underlying LLMs, writes the code, and its expert tuning means it's faster and more accurate than general purpose AI. So let's pause here. Alejandro, what has Nigel done so far?
Yeah, so Nigel already wrote my Python test. I can see here Measure IQ. It's using the NIDC Power gRPC API, which is really great. And it's on its way to write a test and sequence, I believe.
All right. So I want to emphasize an important point. Nigel can code this test faster with fewer tokens because it's leveraging the TNM skills that we have built into it. And it's more likely to get right on the first time compared to Claude Code. That means less time debugging, more time testing. So, you got any proof points of that, Alejandro?
Yeah, Kevin, we have a lot of proof points, but one of them is one of our test engineers had a task that took 20 hours over a course of 2 weeks, and he was actually using AI tools in VS Code to help him. But with Nigel AI, it only took 20 minutes, and it worked on the first shot. Our test engineer didn't have to learn about or teach an AI how to stitch several tools together. That's actually really complex to do. He said it best afterwards. I can now do things with Nigel I could only imagine before.
All right, pretty impressive, you know. So, but what about the power efficiency test?
Yeah, let's scroll up because I thought I saw, this table over here. Here I can see that Nigel found 2 VIs and it picked one. And Nigel doesn't just look at the similarity in the name of the file or even in the structure of the code. It does do those things, but it also uses connection to SystemLink to find real usage data and bring it in and help the conversation. So Nigel picked a VI here. This one over here has about 4,500 actual test results associated with it. This one only had 500, so it went with the first one.
So that's what it means to be deeply integrated with your tools and data. It's not just what looks right on paper. Nigel tells you what's actually worked before, so you have more confidence in your tests. So Alejandro, it looks like Nigel just created a test and sequence in record time. And the conversation doesn't stop there. Nigel and the context stays with you in test stand. You can ask Nigel to tweak the sequence, optimize it, explain what it just did?
Yeah, so Nigel comes with me wherever I go. I've just opened up the test stand sequence in actual full test stand, and I can look through all the settings, and there's my conversation. I can continue it here. So whether that's Nigel goes with me wherever I go, whether that's test stand, LabVIEW, Instrument Studio, or third-party tools. Yes, even VS Code. So let's take a look at a recording I had with Nigel in VS Code. And so here, Nigel's with me in VS Code. I asked him to make a change to the Python file, and Nigel knows to update the test stand sequence as well. The conversation's everywhere. Same thing would happen if I were to do this in Claude Code, OpenAI Codex, Google Antigravity, GitHub Copilot, or whether I was using local models with OpenCode. It doesn't matter. Nigel's there with you, whichever agent you prefer.
So what you just saw is the new normal for test development. AI accelerated everything. Your tools, your models, your workflows. You choose how much AI to use and where to use it. And Nigel is right there with you to make you more productive. So let's look at one more way Nigel can benefit your workflow. Debugging and analysis. We want to test the 5-volt switching ripple on this DUT. So Alejandro, can you have Nigel design an interactive UI using our scope?
You bet. That'll be easy. Let's do it.
Nigel's going to give us a UI that's fully interactive, fully customizable, with all the features you'd expect. Of course, you could build this yourself with enough time, or you could spend days with a general-purpose AI, fighting prompts, vibe code bugs. But Nigel can build it in seconds. No code, no configuration. Nigel knows how to talk directly to our hardware.
Yeah, let me just send this prompt here to continue configuring my panel. Yeah, Nigel's connected to my PXI right here remotely through our gRPC drivers, and we're streaming back live waveform data right from the scopes. I also prompted Nigel to show me my harmonics. So that's this over here. I can see the switching ripple on the 5-volt rail, and it looks a little different than I remember. So let's go a bit further beyond and see if I can overlay live historical data with the live data so I can compare these results with what I saw last week. There it is.
All right. So this is a fully custom chart that Nigel made on the fly. Nigel's pulling historical 5-volt measurements, computing a mean, tolerance band, and rendering it behind the live trace. From there, you can customize anything, add features, change layouts. You can use it as a starting point for something much bigger. Nigel even saves the UI as source code, so you can use it in a variety of applications.
Yeah, Kevin, this is a game changer for debugging. Nigel computes statistics and overlays them on my data for context. I can see in real time how this unit compares to the historical population. I can spot outliers or early signs of drift immediately. You know what? Let's print this out so I can share this with the team. And I have an old printer I found.
I think it's a dot matrix printer.
It's really loud.
I'd rather talk. Okay. So I think this shows Nigel can connect to any tools you use, whether it be modern MCP or vintage printer. Now, since I don't have the time for wait for this, I think turning it off was the right answer. But anyway. So why don't you just send me a link?
Yeah, we can just share this with you. And hey, from NI Connect 2026. All done. Shared it with you.
Thank you, Alejandro. So what you just saw is more than consumer AI or generic assistant. You saw Nigel working as a trusted agent using open language agnostic tools grounded in deep TNM expertise and proven IP. So wherever you are in your workflow, whether you're designing a test system, implementing a test sequence, or building a custom application, Nigel will help you be more productive and get you more meaningful insight from your measurements. Thank you.
Well, you guys said go fast. I think it's incredible to see how far we have literally come since first introducing Nigel just a year ago on this stage. And I think it's even more exciting to get a chance to see where we're going. You know, Nigel is growing every day and becoming a better advisor, a better author, and soon a better agent. And as we're doing this, we're being very, very intentional with this new capability of building it on our trusted AI-ready platform. Because as we continue to ride the wave of the latest AI technologies, we absolutely must ensure that we do so in a test and measurement optimized way that you can trust. So going back to the start of the keynote and our theme of the genius of the and, it's clear that we must remain trusted and industry ready and be highly innovative. We must evolve our current products and platform, and we must be open to entirely new ways of working. We must find a way to be both familiar and breakthrough. AI is changing the world around us, and I know we're all a little bit trying to predict the future. We have a gut that AI will be more than a coding assistant or a data assistant, but will it be the savior of test and measurement, or will it be a lot of hype? Will you need to invest more in purpose-built tools, or should you just vibe code everything with an LLM because you can? Should you use more LabVIEW, or should you use Python? The trap of the tyranny of the or is a very, very dangerous one. And while your resources, your tooling, your process may have limited you in the past, I encourage you, please guard that an either-or mindset isn't what holds you back in the future. Now, if we look back at the rich history of technology inflection points, maybe for some innovations, concepts like the Jevons paradox suggest as the cost and ease of a new technology improve, its use and importance often rises in significant and unexpected ways. When we got better at using coal to build steam engines, we got the Industrial Revolution. There's maybe a world market for 5 computers turned into one on every desktop, every pocket, and every wrist. And when the PC transformed document creation, we used far more paper rather than less, as the pundits predicted, which is why I believe this is our time. I am incredibly optimistic about the future of test and measurement. If I could leave you with just a little thought experiment this morning, what if the cost of making an additional measurement fell to 0? What would you measure? What insight would you be looking for? What nagging questions do you have about your product or your process that may just be a question away from being answered? I hope you're as excited as I am about finding answers to these questions together. And I hope this week, with the sessions and the demos and the conversations you'll have with each other, you feel inspired into this AI future. Thank you so much for being our loyal customers, and thank you so much for joining us in Fort Worth to celebrate our 50th birthday. You guys have a wonderful conference.